Well, welcome to MV Tutors. If you'd like to book a session after this, go ahead and visit our website and book a session over there. You will find the website under the description of this video. But we are now talking about the difference between aldehydes and ketones. Let's get right into it. Let's start talking about the aldehydes, okay? Before we get into the difference, let's just talk about the aldehydes on their own. The aldehydes, they have a functional group of, you have a double O there, and then you have a H and a C this side. Okay, so that's the functional group. Now, let's just see typical examples of the structural formula. So you'll have 1, 2, 3 C's. Okay, and then let's just go ahead and put, not there, put our functional group right over there. Okay, so these ones are bonded to H's. Okay, let's do another example. So this one will have 4 of them. 1, 2, 3, 4. And then we'll put our functional group right over there. Okay. These ones are bonded to, just a note, oxygen is always bonded twice. Okay. Carbon is bonded 4 times, 1, 2, 3, 4, while hydrogen is bonded once only. Good. Now let's go ahead and name these things. Now they have a suffix. Okay, the suffix of an aldehyde is al. Okay, so here we have 1, 2, 3. 3 is prop. Propane, and then the suffix al. So propanol. Okay, this one is 1, 2, 3, 4. 4 carbons, that's a butane. And then butanol. It's a butanol. Okay, now let's talk about its condensed structural formula. Condensed structural formula. All right, so it's taken from the structural formula. So we just look at the number. The first C is bonded to 3 H's. The second C is bonded to 2 H's. And then the last one, it has, now the way you write this one is that you start with the H. It's always CH, and then you put the O at the end. This is very important. You don't put OH because now that would make it an alcohol if you put an OH. So you have to put it as HO at the end. Okay. So likewise, this side for the butanol, the first C is bonded to 3 H's. Second one is bonded to 2. Third one is bonded to 2. Fourth one is 1 H and an O. Okay, so that's the condensed structural formula. Let's now discuss the molecular formula. The molecular formula. Okay, so the molecular formula, you write it, you start with the number of C's. How many C's do we have here? 1, 2, 3. So we've got 3 C's. And how many H's do we have? We have 3, 4, 5, 6. And then we've got an O, just like that. Okay. This side can also read it from the structure. How many C's? 1, 2, 3, 4 C's. So you've got C, you've got 4. How many H's? Let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 of them. And then how many O's? We've got just one O. That's it. Okay, now let's discuss the next one. Okay, which is our ketone. Right. Now, ketones. Now, the functional group of a ketone is such that you have a C, you have an O, then you'll have a C this side and a C. Okay, that's the functional group. Let's go ahead and do an example. So, a structural 1, 2, 3, and then we'll put our O over there. This side will have 1, 2, 3, 4, and we'll put our O over there. Okay, and then the rest are bonded to H's. Okay, now let's get to the naming of this thing. The suffix. Okay, so now the suffix of this, as you can see from here, is own. It's not one, you pronounce it as own. Okay, so in naming this 1, 2, 3, that's a prop. N. So it puts the suffix now on, which makes it proper noun. Okay, this side 1, 2, 3, 4, that's a butan, and then you put the suffix butanol. Okay, that's it. Now we need to discuss the condensed structural formula. The condensed structural formula. So for this one, okay, you look at the first C. How many H's does it have? It has 1, 2, 3. The second C, it actually has an O. Okay, and then we have the last one is CH3. Okay, that's how we do it. All right. And then for this one as well, you look at the first C, it's got 3 H's. The second one, it's got 2 H's. The third one, it has an O. And then the fourth one, CH3, 3 H's. There's another one there. Okay, now the last discussion we have to do before we make the difference: molecular formula. The molecular formula. Okay, so from the condensed structural formula, counts the number of C's. We've got 1, 2, 3. So it's C3. The number of H's, it's 3 plus 3, which makes it 6 of them. And then you've got 1 O. Likewise, also this side, you can use the structural formula. You count the number of C's. It's 1, 2, 3, 4. 4 C's. So C4. Then let's go and count the number of H's. We've got 1, 2, 3, 4, 5, 6, 7, 8. We have 8. And then number of O's, we've just got 1. Right there. Okay. Now, what is the difference between the two? You might have not noticed, or you might have noticed, it's the functional groups. So As you can see, the functional group of aldehydes is at the end of the chain. It's always going to be at the end. If the functional group, the O, is at the end, then that makes it an aldehyde. Okay, but if the functional group, as you can see here, is somewhere in the middle, it's not at the end, then that makes it a ketone. So the difference is the position of the functional group. If it's at the end, it's an aldehyde. If it's somewhere in the middle, it's a ketone. Otherwise, they both have the same molecular formula, as you can see over here. The molecular formula is the same. It's just the difference is in the positioning of the functional group. That's it. Thank you very much.